Hello everyone. In this session, let me continue the problems on Cauchy's integral theorem and Cauchy's integral formula. So this question is a bit different. So as we already done this, but equation of curve is not given directly. In this problem, we have to evaluate this integral and make sure that it is of the form f of z divided by z minus a, but the power is more than 1. So we have to apply the Cauchy's generalized formula. So as I already told you, when the power is greater than 1, we have to apply Cauchy's generalized formula. Now, a curve is a boundary of a square whose sides lies along the line x is equal to plus or minus 4 and y is equal to plus or minus 4, described in a positive direction. In the sense, curve is given as, like, let me take a axis 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So, y will be positive here, 1, 2, 3, 4. And negative here, so minus 1, minus 2, minus 3, minus 4. Fine. So, clearly in the problem it is given x will be ranging from plus 4 and minus 4. So, x is plus 4 here and minus 4 here. Fine. Again, y will be plus 4 to minus 4. So, it is something like this. Fine. So boundary given is a square. I'm telling you again, notes of this problem will not be sent in the group. Please copy the notes by seeing the video. So it is a square. Fine. So x is equal to plus or minus 4 and y is equal to plus or minus 4 in the positive direction. Now we have to evaluate this integral over this. Now let me write down the given integral. It is e power of 2z divided by z minus pi I whole power of 6. The thing is that we have to decide whether the point A lies inside the given curve or not. Now when we compare it with the standard form z minus a value is pi into I. So it is, let me express it in a complex number form, that is x plus iy. Here you can note that x value is 0 whereas y value is pi. And moreover, clearly pi in the sense it is 22 by 7. So it will take value 3.14. So 3.14 clearly lies inside the curve. Right? So given curve is a square, I have drawn clearly. So the obtained value is 3.14 here. Right? So 3.14 lies clearly inside the given curve. So let me write one statement. The point A lies inside the given curve. So as I already told you, when the point lies inside the given curve, we have to apply Cauchy's integral formula. But here the power is more than 1. So we have to apply generalized Cauchy's integral formula. So let me write, therefore, by generalized is also same as extension. Generalized Cauchy's integral theorem or integral formula, that is generalized from what we have, f power of n of a will be equal to n factorial divided by 2 pi I into integral over f of z divided by z minus a power of n plus 1 into dz. This is the generalized form. So let me do cross multiplication. So you will get 2 pi I into f power of n of a divided by n factorial. So when the integral is of the form f of z divided by z minus a power of n plus 1 into dz. Fine. Now comparing with the original form, what is the original form we have? That is given problem is e power of 2z divided by z minus pi into I power of 6. Right? So how can I write 6 as? I can write this as 5 plus 1 just to compare with the standard form. Now compare this with the standard form. So thereby I can write that f of z value is numerator, that is e power of 2z. Fine. And moreover n value is 5. Fine. So I can apply the theorem directly. So I'll get 2 pi I into f power of, here n value is 5. So I have to differentiate 5 times and a value is, let me write here only, a value is pi into I. So f of pi I divided by n factorial, n is 5. So you will get 5 factorial here. Fine. So 2 pi I divided by 5 factorial into f we have to differentiate 5 times. Now f of z value I have here, so let me simplify here only. F of z value is e power of 2z. Fine. So first let me differentiate one time. So what you're going to get is f dash of z is equal to 2 into e power of 2z. Again, second time when you differentiate, what you're going to get? 2 again you will get. So I can write this as 2 square into e power of 2z. Again I am going to differentiate 3 times. Again you will get 2 here. So I can write this as 2 cube into e power of 2z. Again differentiate with respect to z. 2 for 4 into e power of 2z. Since we need fifth derivative, so fifth derivative will be 2 power of 5 into e power of 2z. So I need the value of f of fifth derivative at pi I. So I have to replace e with pi I whole power, e as it is, I have to replace z, right? So e power of, it is e power of 2 into pi with z with pi I. Fine, I am going to write it again. So since what I have obtained, fifth derivative of function is 2 power of 5 into e power of 2z. But what I need is fifth power at pi into I. So I have to replace z with pi I. So wherever z is there, you just replace it with pi into I. So what I have obtained is, let me write one more step. So I'll write here. So I can write the given integral e power of 2z divided by z minus pi I power of 5 plus 1 will be equal to 2 pi I by 5 factorial into f at fifth derivative pi I value we have to substitute, and I have obtained it as 2 power of 5 into e power of 2 pi I. Hope so it is clear. Right, now let me simplify one more step. So 2 pi I will keep it as it is, divided by 5 factorial into 2 power 5 into 5 is 2 power of 6 I can write. So e power of I theta. So remember, as I already told you in the basics, so e power of I theta, how can I write this as cos theta plus I sin theta. Right, similarly e power of 2 pi I theta. 2 pi I, right? So whenever I have in place of I theta I have 2 pi I theta, so I can write this as cos of 2 pi I plus I into sin 2 pi. Clear? Cos 2 pi plus sin 2 pi. Now e power of 2 pi I, I'll just simplify here only. I have already told you that cos n pi value is minus 1 power of n. So cos 2 pi value is minus 1 square, it is plus 1. Plus I into sin n pi value is 0. So sin 2 pi value will be 0. So what is the value of e power of 2 pi I? It is 1 plus 0 is 1. So I'm going to put it as 1. So what is the required solution? Integral over c e power of 2z divided by z minus pi I power of I plus 1 is 6 is equal to 2 power of, if you want you can simplify this also, 5 factorial if you want you can simplify, otherwise you can keep as it is, one and the same. But you have to put the factorial symbol here. Clear? Further, if you simplify this by expanding, you will get 2 power of 3 divided by 15. 5 factorial you have to simplify and substitute the value, you will get this. Either you can keep this or you can keep this, one and the same. So hope so it is clear. Everything is same, but the difference is that here the given curve is square, so we have to draw the curve and make sure that whether the curve lies inside or outside. So in the given problem it lies inside, but we have power more than 1, so I have applied generalized form, thereby I have obtained solution as 2 cube by 15 into pi I. Hope so it is clear. Now let me solve the last problem in the same concept. So here is the problem. Anyhow, I have already solved one problem of the same kind, where a curve equation is ellipse. But the difference is that we have to evaluate all these values. So let me evaluate first one, that is f of 3.5. Fine. So when the problem is like f of 3.5, the meaning is it is of the form f of a. So you have to replace, I'll just write here, it is of the form f of a. So you have to replace a with 3.5. Therefore, for the first problem, integral become 4z square plus z plus 5 divided by z minus a value I have to put as 3.5. Clear? Now we have to evaluate this integral. Now what is the given curve for us? It is x square by 4 plus y square by 9 is equal to 1. Now in place of a, as I already told you, when it is 3.5, it is of the form like 3.5 plus 0 into I. So it is x plus iy form. I have to replace y with 0 and x with 3.5. So when you do that, you will get 3.5 whole square divided by 4. So obviously check whether it is greater than 1 or not. So 3.5 whole square will be 7 divided by 4. Again it will be greater than 1 only. So you'll get again 3 point something value. Whatever may be the value, if you want you can calculate and check. You will get definitely greater than 1. Value greater than 1. So as I already told you, when the value is greater than RHS value, I can clearly say that therefore the point greater than 1. Therefore the point, what is the point here? 3.5 lies outside the given curve. Outside the given curve C. So as I already told you, when the point lies outside, we can apply Cauchy's integral theorem. Therefore, by Cauchy's integral theorem, we have to write full form. Cauchy's integral theorem, what is the value of the integral? It goes to 0, right? So you have to write the theorem also. Integral f of z into dz is equal to 0. F of z by z minus a into dz is equal to 0, right? So 4z square plus z plus 5 divided by z minus 3.5 value is equal to 0. Hope so it is clear. The same procedure, whatever the problems I have solved, so you have to do the same procedure. I'm sorry, Cauchy's theorem, right? So it is integral f of z dz is equal to 0. So we have obtained the value for first one. Now I have to evaluate the second one. So let me do here. I have to find f of I value. In the sense, I have to replace a with I. So let me do that. So given integral can be written as 4z square plus z plus 5 divided by z minus a. I am replacing a with I. Why? Because I have to find f of a value. Now I, in the sense, it is of the form what we say 0 plus I form, right? So y value here is 1, x value is 0. So given curve is x square by 4 plus y square by 9 is equal to 1. Replace x is equal to 0 and y is equal to 1. So 0 plus 1 divided by 9. 1 square is 1 only. So 1 by 9 will be obviously less than 1. So as I already said, when it is less than 1, the given point lies inside the curve. Therefore, the point A lies inside the given curve. So when it lies inside the given curve, so I'm sorry, this is Cauchy's theorem. So when it lies inside the given curve, we have to apply Cauchy's integral formula. Therefore, by Cauchy's integral formula, how can I write f of z divided by z minus a into dz will be equal to 2 pi I into f of a. Right? So what is the value of f of z here? Compare with the standard form. I am going to compare this with the standard form. That is 4z square plus z plus 5. Fine. So I can write 4z square plus z plus 5 divided by z minus I into dz will be equal to 2 pi I into f of a. A value here is I. So I have to find f of I. Now in f of z, replace z with I. So I'm going to replace here z with I. You will get 4 into I square plus I plus 5. So you will get I square value is minus 1. Minus into plus is minus 4 plus I plus 5. So 5 minus 4 is 1 plus I. So f of I value is 1 plus I. So let me replace here. It is 2 pi I into 1 plus I. So this is the required solution for the second one. Hope so it is clear. Now similarly, let me solve the third one. But third one, what we have? Derivative, that is f dash of minus 1 and f double dash of minus 1. Anyhow, let me do that. So third one what we have to find is f dash of minus 1. Anyhow, whatever may be the derivative or the function, a value is minus 1. So let me replace 4z square plus z plus 5 divided by z minus a value is here, a value is minus 1. So I am going to replace it with minus 1. In the sense, minus of minus will become plus 1. Clear? Now we have to find whether the point lies inside or outside. So when you compare, a value will be -1, right? So in the sense, I can write this as -1 plus 0 into I. Now given curve equation is x square by 4 plus y square by 9 is equal to 1. Now replace x with 1 and y with 0. So -1 whole square will be +1. 1 divided by 4 is always less than 1 only. Fine. So when it is less than 1, we can clearly say that the point lies inside the given curve. Right? Therefore, the point A is equal to -1 lies inside the given curve. So as I already told you, when it lies inside the curve, we have to apply Cauchy's integral formula. So what it says, f of z divided by z minus a into dz will be equal to 2 pi I into f of a. Comparing, f of z value is 4z square plus z plus 5, right? And a value is -1. Fine. So therefore I can write integral 4z square plus z plus 5 divided by z plus 1 will be equal to 2 pi I into f of I. A value is -1. So let me find f of -1 value. That is, replace z with -1 whole square minus 1 plus 5. So what you're going to get is -1 whole square is +1. +1 into 4 is 4. -1 plus 5. 4 minus 1 is 3. 3 plus 5 is 8. So f of -1 value is 8. So let me replace 2 pi I into 8. So what you're going to get? 16 into pi I. Let me check once again. Yeah, we have done correctly, but what I have done is I have find out the value of f of -1. But what they have asked us is we have to find f dash of -1. So we have to differentiate the function. Now what is the function given to us? F of z, right? So we need the value of f dash of -1. So we have to differentiate f of z. So let me do here f of z. I am going to differentiate f of z. You will get 4 to the 8. 8z plus differentiation of z is 1 plus differentiation of I is 0. Now we have to find f dash of -1. 8 into -1 plus 1. So you will get -8 plus 1. It is -7. So I am going to replace here only -7. Why I have done this? Because we have to find f dash value. Remember, go through the question. If they asked you to find f of -1, you have to do like this. Since in the question they have asked us to find f dash of z, so I have differentiated the given function and then I have substituted a value so that I have obtained this. For 2 into 12 is -14. Fine. Therefore, integral 4z square plus z plus 5 divided by z plus 1 value is -14 into pi I. Clear? Now the fourth one, what we have? F double dash of -I. That is, we have to differentiate the given function twice. Fine. Anyhow, let me do here. Third one, hope so it is clear for you. Fourth one is, what is the given problem? We have to find f double dash of -I, right? So given integral will become 4z square plus z plus 5 divided by, here a value is -I. So minus of minus will become plus I. That is z plus I into dz. What I am doing is I am replacing a with -I. So I will get z plus I into dz. Fine. So here the value of a is, so I in the sense 0 plus, a value is -I. Right. So a value, compare it with z minus a form. So it will be a is equal to -I. I can express this as 0 minus I. So here x value is 0, y value is -1. Right, x plus iy form, you do that, and when you substitute in the given curve equation, you will get -1 square is 1. 1 by 9 is always less than 1. Right, if you want, I'll do here. See here, x square by 4 plus y square by 9. I have to calculate. X is 0, y square is 1, 1 by 9 is less than 1. So 1 by 9 less than 1, when the point is less than, given point will be inside. Therefore, the point A is equal to -I lies inside the given curve. Inside the given curve. So we have to apply Cauchy's integral formula. Write down the Cauchy's integral formula statement. Now comparing f of z value is 4z square plus z plus 5. So what we need is f double dash, right? So let me differentiate 2 times here only. F dash of z will be 4 2 is 8. So 8z plus 1. Again f double dash of z will be differentiation of 8z is 8. 1 is constant. So f double dash is 8. Now let me apply the theorem directly. You have to write the theorem statement once again, but I am not writing here. Find z plus I into dz is 2 pi I into f of a. A value here is minus I. Z minus a form you compare, so you will get a value as minus I. So I am replacing here f of minus a value is minus I. So I need the value of f of minus f double dash of minus I here. Fine. F double dash of minus I will be 8 only. So 2 pi I into 8. 8 2s are 16. Clear? And one more thing is that you have to remember, since they have asked us first order derivative. So in the Cauchy's generalized form what we have, that is when we have a first order derivative I have written somewhere else. That is what we have f of z in the previous problem I have written. See here, f power of n of a is equal to n factorial by 2 pi into f of z by z minus a power of n plus 1 into dz. So when the first order derivative, that is n is equal to 1, you will get divided by 1 factorial. So when you are going to solve for second order derivative, you have to put n is equal to 2. So you have to divide it with 2 factorial. See here, in the third problem we have solved for f dash. See here, f dash of z we have solved. So I am dividing it with 1 factorial. No, anyhow it is it doesn't make more difference. But here we are solving with the second order derivative. Please don't forget to divide it with 2 factorial. So I have to divide it with 2 factorial. Clear? So the required value will be, let me write here, 16 pi I divided by 2. So 2 ones are 2 8s are. So required answer is 18 pi I. I am repeating once again, when you are going to solve f double dash. Why? Because fourth problem is f double dash. So when you are going to solve f double dash, you have to differentiate the function twice. So as per the theorem, you have to divide it with 2 factorial. So 2 factorial value is 2. So I have simplified. It will get, I will get 8 pi I. Hope so it is clear. So this completes the problems on Cauchy's integral theorem and Cauchy's integral formula. So today's session notes will not be sent in the group. Please copy the notes by seeing the video. Hope so it is clear. So in the next session I will be continue with the theorems. Thank you.